All right, today I'd like to talk to you about types of chemical reactions. So we left balancing chemical reactions back before we started doing mole conversions. So we're going to return to balancing chemical reactions, but this time we're going to do something a little differently with them. So first of all, we can actually classify chemical reactions based on what happens. So chemical reactions only happen if there's an actual chemical change. I just want you to know, just because you mix some chemicals together doesn't mean that a chemical reaction takes place. A gas, a liquid, or a solid must form in order for a reaction to happen. All of them that I'm going to show you are going to be reactions that actually happen. You can do this such that we can say, does a reaction happen or not? And it's based on certain things, which we'll talk about today. So there are three basic types of chemical reactions. You can also base them on like the energy. You can say they're endothermic or exothermic. All of them are going to involve energy, and they can either be classified as either. However, if we look at what they form and what happens to the reactants and the products, then we can classify them like this. They can be either precipitation reactions, oxidation reduction, or acid-base reactions. So a precipitation reaction is when a precipitant or a solid that's insoluble in water, meaning it doesn't dissolve, forms, or oxidation reduction, which we haven't talked about that yet. Hopefully we can get to that before the end of the year. But that's when something is oxidized, when something is reduced. So that means some part of the chemical reaction, things lose electrons and other things gain them. And we all know that chemical reactions happen because of the transfer or sharing of electrons. Or acid-base reactions. And that has to do with acids reacting with bases, forming neutralization reactions. Then oxidation reactions are three types. Combustion, like as in fire, fireworks, that kind of thing. Synthesis, meaning you make something, and decomposition, where something decomposes from something. Okay? So in order to figure out whether or not a reaction takes place, we need to have what's called the activity series. And you'll find various types of activity series in various sources. For example, the one in the chemistry textbook that I have that I don't use has one type. The one that you're going to see in the CK12 has a different one. My college chemistry textbooks have a different one. And then there's this one. So they're all going to have similar metals in them. Some have other metals. Some don't have some of these that are listed here. Okay. But you're not going to have to memorize this. You're going to actually just use this as you move through these lessons in the next week or so on balancing types of reactions. So we can say that all of these are in order by decreasing reactivity, and all of these can replace the ones below them. So lithium can replace any of them in any of these three groups below them. So can calcium. So can iron, and so can silver. But silver can't replace tin, but tin can replace silver. Got it? The other is they can replace a hydrogen in water and acids. So these are highly reactive. You've probably seen Miss Cup has done, like in middle school, the sodium and water reaction. I do the calcium and acids. That's fun to do. And then, of course, each can replace the metals below them. Okay, for example, magnesium can't replace sodium, but sodium can replace magnesium. These are less reactive, therefore they tend to only replace the hydrogen in an acid. Okay, and then these are most unreactive, and that's why you tend to find them as like not an ore, but like in their pure form in the ground. Like you can go pan for gold, silver, and platinum and copper. Okay, again, this is not just like the list. You'll see there's a variety of these out there. Just all depends on what source you're looking at. Some of them have more elements on them than others. Okay, so just keep mindful of that they vary. You just need to know how to read it and how to use it. Okay, but we can also talk in terms of activity series of halogens, which are that group 17 nonmetals. So fluorine can replace chlorine, bromine, and iodine, for example. Okay, so I have included these two as some slides in one of the lessons, and you'll just want to go back to it as you use these materials. Okie dokie. All right, so let's look at the different types of reactions. The first type is a single displacement, or you'll hear it called single replacement. And that's just when one element takes the place of another in a compound. So for example, if we had, and by the way, in this unit or chapter, or this particular topic of study that we're going to look at, you're going to see these S's and L's and G's and AQ's in parentheses, and they are representing the state that they're in. So S is for solid, AQ is aqueous, and L is for gas, and L is for liquid, and G is for gas. Okay, so if I had just simple iron solid, and I placed it in a copper sulfate solution, copper 2 sulfate solution. This is a solution, and it would be a blue colored solution. And you can do this easily in the lab. In fact, I've actually done this before with my students. The iron will kick out the copper. So if you look back here at the iron and copper, here's iron, here's copper. So you can see that iron takes the place of copper. Okay, so iron can take the place of copper, and then as a result replaces it and makes iron sulfate, iron 2 sulfate, as opposed to iron 3, or copper 2 and copper 1, and then you end up with the copper as a precipitant. So this reaction does actually happen. Now, if you'd replaced some other solution that iron doesn't replace the metal, then the reaction wouldn't happen. But the fact that we formed a precipitant, which is a solid, the reaction actually happened. Okay? So you can look at it like this. Some element X replaces element Y in a YZ compound to make Y and XZ. Here's another example. For example, if we had aluminum and iron 3 oxide, you'd make iron and aluminum oxide. And then same thing here with the halogens. Remember, chlorine can replace bromine. So it doesn't just have to be metals and compounds and solutions. It can actually be solutions and solutions, and they can be the halogens, not other nonmetals. Okay, so in this case, chlorine replaces bromine to make just bromine. All right. A double displacement or double replacement. It's where the positive portions, and that's key, of two ionic compounds are interchanged, and at least one of the products is a precipitant or water or both. It could be both. And it doesn't have to be two ionics, because in an acid-base reaction, it's the two positive portions of just two compounds. So for example, a positive portion of an acid taking the place of the metal in an ionic compound. A precipitant is nothing but an insoluble solid. In this case, this is chromium in a solution, and you're making a chromium precipitate here that is insoluble. And they're not yellow, they can be white, they can really be any color. So here's an example. If we had lead 2 nitrate in a solution reacting with potassium iodide solution, we mix these two solutions together, we're going to get lead 2 iodide. It's insoluble, because if we look at the solubility rules, you'd see that iodine with lead, halogens with lead tend to be insoluble, which you'll learn about that later, and you make potassium nitrate. Okay, so if we had mixed this solution with some other solution that wasn't reactive, then you'd make nothing, and you just have no reaction. You just have two solutions mixed together, and you didn't make anything new. Okay, so that's something to keep in mind. You have to form a solid, liquid, or a gas in order for the reaction to take place. Another way to look at it symbolically would be compound XY reacting with compound AB to make compound XB and compound AY. And here's some more examples. We have lead 2 chloride reacting with lithium sulfate. Again, compounds with lead are insoluble. We'll talk about solubility rules later. You end up forming lead sulfate and lithium chloride. Again, barium chloride reacting with sulfuric acid, in this case an ionic compound with hydrogen, because barium can replace the hydrogen in an acid, and you make hydrochloric acid and barium sulfate, which is insoluble. Compounds with sulfates are insoluble. Okay. Synthesis or combination, I think, is the other term you'll see in either like the CK12 lessons. It's where two or more substances form a single product. Example, iron reacting with oxygen to form iron 3 oxide or rust. So X plus Y making XY. And then here's an example with sodium reacting with chlorine gas to make sodium chloride, calcium oxide reacting with silicon dioxide to make calcium silicate. And the other type, which is just like a reverse of synthesis or combination, is decomposition, where a compound breaks down into two or more simpler substances. So if we had like ammonium nitrate, it could decompose into dinitrogen oxide and water. So compound XYZ making compound XY, X, Y, and Z. Or you can even just say this could have been compound X, Y, and Z, or compound X, Y, and Z. So just depends on what the compounds are. And some more examples. We have phosphorus pentachloride decomposing to phosphorus trichloride and chlorine. And then silver oxide, silver 1 oxide reducing to silver and oxygen. Notice when you come up with the products here, there are familiar things that like diatomics are always good to make, or single elements by themselves. Okay. And then the last type is a combustion, where any organic substance, which is any compound containing carbon, combines with oxygen to form one or more oxides. So, for example, if we have ethene reacting with oxygen to make carbon dioxide and water, and you don't have to have the energy, just letting you know that there's always energy that's released in this process, but it can be any CH or any CHO with any subscripts, always combining with O2, and then the two products are always CO2 and water, are always CO2 and water, okay? So anytime you see carbon reacting with oxygen, you're going to always have products of CO2 and water. And then here's some more examples. This is natural gas or methane reacting with oxygen to form carbon dioxide and water. And then you have glucose in the form and respiration. You've seen this before in biology, combining with oxygen to make carbon dioxide and water. All right, that's all for now. Talk to you later. Bye.